I do everything I can to get a catchy title, right? So thanks everybody for inviting me and having me come to talk today. I'm a little bit, for those that don't know me, I'm a little bit new to the OVS world. Spent a lot of my time doing kernel development and platform work for a long time at Red Hat and Cumulus Networks and a couple places. But right now I'm at Broadcom, and we're here to talk about kind of the rise of an interesting SmartNIC product. Several people have touched on the questionable name of SmartNIC. Does that make a non-SmartNIC a dumb NIC? We're going to go the phone route and call it a feature NIC. I don't know. We'll see how it goes. But for now, until someone comes up with a better name, we'll probably stick with SmartNIC and try to not make fun of people who don't have one that's smart. But that's OK. All right, so today we're going to do a little bit of a case study on Open vSwitch offload to a SmartNIC. Unsurprising, this is the offload track. And I know it's Friday. It's 2:10, 2:11. It's getting late. We're tired, so appreciate everybody sticking with us. So talk a little bit about the data path acceleration user experience, what that's like right now. We've heard a lot of discussion about it. A lot of it's extremely positive. I tend to agree. It's very positive. But there are some issues. I'm going to also try to define a little bit what we like to think about as the difference between acceleration and offload. I think it's an important point. I'll talk a little bit about the SmartNIC, software data path config, our forwarding capabilities, because, ooh, everybody loves performance slides, except marketing people. And then I'll talk about sort of what's next, so pretty standard. So again, we all know the answer to this question. Why do we want to accelerate Open vSwitch data path? So we want to use the server processor cycles for actual work. I mean, Rasha just gave a great presentation that I think really nails this point home. That's really the advantage here, is we can throw more cores at the problem. We can use a quarter of our system. We can use half of our system. We could use an entire socket as we get up to higher speeds. But the real benefit is that we want to use those cycles for actual work, whether you're leasing them out to somebody else or using them for your own workloads. But let's talk a little bit about the experience right now. So vendors have worked tirelessly to make sure flows can be accelerated by NIC hardware. Broadcom is no different. We have a solution. We have a true flow hardware component, we call it. And we support acceleration in that method. And we actually, as seen in the slides earlier, support it in the same way that the other vendors do right now upstream via TC. So the CPU utilization, again, number of cycles used, is reduced significantly when we offload megaflows. And this workload really, really amped up the improvement when we talk about 25, 50, 100 gig speeds. Maybe 10 wasn't such a big deal because you could come close to handling your load. But as we get bigger, it's really important. The other big thing to think about, and it's been highlighted, and I don't do it to make fun of anybody or poke holes in any vendor solution, ours included, but let's get real. The acceleration capabilities are always going to trail software capabilities. That's just going to be the case. My experience in the past with this, I was heavily involved in the switch dev infrastructure, which was created in the Linux kernel. And we were constantly chasing. And it works, and it's great. But there are still holes. There are things that are going to be missing. So it's something to always remember. So rather than accelerate the data path, our proposal is that we just want to offload all the things. So this is not too different from the presentation we also watched this morning from Cavium. In fact, as I was watching it, I was sort of like, how quickly can I redo all my slides? Because it's pretty much the same. I mean, we're in kind of the same space here. Everybody's thinking about what can be done next and how can we offload. So again, I'm going to go through, and I'm going to try to use this language as much as I can. You can choose to, or you can choose to not. So acceleration, virtual functions in switch dev mode on the server. In our case, we program our TrueFlow hardware to forward traffic without sending this to the software data path. Those are good. Save cycles. Downside, contract and friends, not really accelerated. Now, in the offload case, as we've seen, we don't do any flow programming or data path work in the server. Open vSwitch and apps and all the data path are handled in a SmartNIC. Traffic is directed to the VFs by the SmartNIC, of course, because in our case, we still talk about that. And in the other use case this morning, same thing. And the great thing is that all current software features of Open vSwitch are actually supported. Now, of course, there's a caveat here. If you're using DPDK versus kernel mode, you're going to see a difference in the full contract support in terms of NAT and some of the other application level forwarding things. So, right, picture, not surprising to most. We've got these are the core, the key components. And in this one, of course, we've got our true flow data path cache pictured there because it's extremely useful not only for sending traffic between VFs, but actually if we wanted to offload some. So what does the SmartNIC software config look like? Well, as I said, we don't have any tools running on the server. We just install our SmartNIC and create the VFs. That's it. You're done. So our SmartNIC is responsible for doing all of the forwarding between the VMs and the rest of the network. Our common friends applications that run on a regular basis, all of them, SmartNIC, completely. And again, as I mentioned before, VF forwarding policy is completely controlled by the SmartNIC. So, proof. All right, here we go. Here's my server. What's running on it? Absolutely nothing. Nothing there. What's running on my SmartNIC? There we go. So this is exactly what I did. I actually took this capture just yesterday or 2 days ago. So we're not doing anything. I'm not making it up. So this is what our situation would look like now. So unsurprising, the box looks almost identical, but with a new black line and 2 key new words, stingray and SmartNIC, where everything is encompassed inside there. And now the VFs that are created that may be assigned to a VM, maybe not if you're VirtIO based or you want to have migration capabilities, all that is encapsulated right there. It makes our server extremely boring, which is good, right? I mean, this is what we want. We want these things to be simple enough that at times it almost seems boring. So I'll talk a little bit about what's in our SmartNIC as well. So in our case, it's 8 A72 cores. I've seen a couple different flavors, and of course I see things a little bit before other people. At least that's the hope since I'm internal. We've got 8 or 16 gigs of RAM. In this case, I've got a 2x25 port. Good note, Broadcom TrueFlow is supported on this. So for those that are used to using our 25 or 50 gig NICs right now, or 10 gig that have the hardware offload capability, that IP block exists in this SmartNIC as well. So you have the chance to do offload if you want, or acceleration. See, I'm already doing it wrong. You have the chance to do acceleration if you'd like. And right now it runs a version of Yocto Linux, and we have an upstream kernel. So the key differentiating point for us, I think, compared to what you'll see other places, is that it truly is like an open programmable platform. So if you're a user, you decide what applications or Linux distributions you want to use. People aren't tied to Yocto Linux. If they like it and are familiar with it, they can use it. If they want to use another distribution that supports 64-bit ARM, that certainly is an option. Know personally, what I've done on this device, because it makes it the most flexible, is I have installed a distribution that maybe has apt capabilities, and I've been able to download and do things like compile my own BPF programs, compile my own open vSwitch, compile my own DPDK right on the target. It's extremely useful and extremely nice. All right, sounds great, right? But the real question is, does it actually work? You know, is this something real? Is this marketing? So maybe it's a little bit of both. It depends. But our performance target for our SmartNIC was using an internet mix of traffic. Can we do 25 gigs of bidirectional traffic? And so what I say when I think about that, I'm going to back up a little bit. Should have put this picture in. And I should have had cool arrows. Credit to the moving ball this morning on the slides from Cavium, I believe. That was great. It would have been helpful in this case. But right, the traffic is coming in the 25 gig port. It's hitting my SmartNIC. It's hitting my ARM cores. It's being forwarded back out to a VF. It's hitting my server. My server's running DPDK. Either, it doesn't even matter if I'm doing IO mode DPDK for test PMD, if I'm doing max swap. The preference would be max swap so your packets get out correctly. But the workload on there is so negligible, it doesn't matter. That's turning it around, forwarding it back out to VF, forwarding it back through the OVS data path in the SmartNIC, and back out the 25 gig port. So this is the full path. For those curious what internet mix is, if you're not looking it up on Wikipedia right now, it's pretty typically, make sure I get it right, I think classified as like 7 or 8 64-byte packets, 4 about 600-byte packets, and maybe 1 full-size MTU 1,500-byte packets. So it ends up working out to an average, I think, of around 320 bytes per packet if you average it out. But that was really our target, and we're pleasantly surprised and happy. Maybe not surprised. We knew it was going to work all along, right? I mean, doesn't everybody? It's where you're supposed to laugh. Come on. I didn't give you a good setup there. But yeah, it actually works, and it's pretty awesome. The first time I fired this up, kind of went through the steps of, all right, let's see what DPDK can do. Okay, that works. That's cool. Let's see what happens when we add OVS DPDK. That works. It's cool. We can run Linux bridging if we want. We could just run pure kernel OVS if we want. Now, those aren't going to be as performant, but the great thing is it works today, and it gives people a lot of flexibility. Of course, if we want to tout acceleration, we can also do that. We do have other flavors of this NIC that are not just 2x25. Might be, I don't know, add them together, or 1x50. And we actually, if we utilize those capabilities, we've got enough processor and space there to do 50 gig. We can get really, really close to 50 gig of bidirectional traffic. Same thing with internet mix. Now, the one bit of data that I didn't provide here, and part of it is some of it's going to be my experience, quite frankly, with Open vSwitch and knowing how many flows people want or knowing whatever. I didn't load this with a certain number of flows or exercise that, but I will tell you that even at this 25 gig bidirectional rate with the internet mix, we've got processor cycles to spare. So this isn't all of the 8 cores or all the 7 cores completely maxed out. We've got room to spare, which I think is very cool and gives us a lot of flexibility. So we'll talk a little bit about what's next. I've talked a little bit about what we did. So last week in Seoul, several people here attended a couple different conferences focused on Linux networking. We talked about ironing out with a couple people here. Some have spoken today, some coming up next. Different VF representer models. So if you're used to using that model, we ironed out what we would want to do with a SmartNIC to talk about how we can have a full picture of your entire server. And then our next real thing is to talk about better integration with Linux distributions that are supporting ARM v8. There are quite a few out there. I think some big announcements this last week about ARM server distributions, and we want to make sure that if you have an interest in running that, you can. If you want to roll your own, that's great too. The other piece is we know that Cavium has definitely got some blueprints out there for OpenStack integration with SmartNIC, and we want to work together with Cavium and the OpenStack community to make sure that that works. And of course, the ultimate goal of every hardware vendor is we want to get more SmartNICs in the hands of more users. So that's all we've got. If you want to have this eye chart of a slide that has a link to the product for this, it's actually right now called the PS225. It's a much less cooler name than Stingray, but you got to have numbers in a name, right? And that's it.
So now I know I should have called these the hardware offload and acceleration sessions.
There we go.
So I know already that we have a question right here, so I'll turn it over to Shiva.
The question is, I did not get a good relationship between, you said that this is a SmartNIC. That means it can go in an x86 server or something like that.
That's right.
So for each and every NIC, are you running an OVS server? Let's say that if I have 2 or 3 PCI cards of the SmartNICs, okay, am I running 2 or 3 of the OVS instances?
Yeah, so this is on this picture that, the Stingray SmartNIC that I'm showing here, to answer your question, short answer, yes. Long answer, which I love, of course, is that this would be on a per PCI card basis. So this PCI card has 2 25 gig ports, so you're not running an instance of OVS DB server and OVS vSwitch D per port. You're running it globally on the card. Okay. But if you had 2 or 3 SmartNICs, which I would recommend in every server you have, then yeah, you would end up running discrete OSs in each one of those.
Okay. Another question is, what's the controller? So they are all going to be talking different controllers or same controller and that kind of stuff. So I did not see the relationship as to how you would have SSL support and GRE tunnels and all the other things. Whatever OVS supports, is that what it is? How do you instrument this?
I'm sorry, I didn't catch that.
How do you instrument these OVS? I mean, how do you set the controller and that kind of stuff? How do you get access to all of these things at the NIC level? Do you go through the OS, or do you guys have tools and that kind of stuff?
Yeah, so what's not pictured so well in this picture, unfortunately, is that there are actually PFs that are in x86 and PFs that are physical functions that are available in SmartNIC itself. And you can put those in the same network, and by default, they're automatically bridged, so they can talk to each other. So if you want to perform, I mean, anything you can do over the network, you can do between the server and that. Does that make sense? Judging by your face,
I was just looking at a controller. Where would the controller reside? I'm sure that it is not going to be on the SmartNIC, it's outside. But how do you program the NIC for saying that, okay, hey, the controller is at this IP address or whatever it is, was my question.
I mean, you have full access to the, I mean, how would you program access to the controller in a server world?
Command line and set the controller.
Same thing.
Sorry,
and I think that was where we're getting there. So there's actually a serial port. You have access to the serial port of the console, or you can SSH in and perform any operation. It really is like another server that you have the full flexibility over. So yeah. Good question. Thank you. Sorry I had to bring that out.
You talk, is this maybe a third? You have offload, acceleration, and now you're looking at yet another CPU, because you talk about you could run third-party applications on NIC. So where's the boundary? Like, could I run a VNF alongside your switch?
Yeah, sorry, I'm having a hard time hearing. There's not a ton of...
Let me try again. You sound as though you have a general purpose ARM CPU.
That's right.
So I could run other applications on that.
Absolutely.
Okay. Maybe it's a third, then I'm saying it's a third category. The acceleration, you have offload, and general purpose NIC.
Yeah, I mean, that's what's kind of interesting. I mean, that's the differentiator from what we heard this morning is there's no SDK, there's not, here's how you load these things in. It's really, you're taking from within your server rather than having it run. You're now saying, well, I've got, maybe you can think of it as an extra machine to administer, which may or may not be great, depending on your perspective. We're seeing, for further use case, we're seeing a lot, this type of solution resonate with people who are leasing out servers, because then they still control the network. So they have the opportunity to say what comes in and comes out of their network, and they then give the person who leases their system the ability to not have to be so knowledgeable of their entire network topology. So yeah, it is kind of a third thing, because are we doubling the number of servers, or if you have 2 or 3 NICs, are we tripling or quadrupling?
I think just quick comment to add to that is basically you are asking for any VNF. Potentially you can run VNFs on those SmartNICs also, so that's yours.
Yeah, thanks.
So I think you raised a really interesting point. I mean, it's kind of an interesting architectural point where you've plugged another server into your server, basically. I mean, it seems pretty general purpose. And so I guess, the sort of, inspires a bunch of questions, should we really, go, rethink things like, backplane architectures and blades where you have, the server's mainly backplane and you can plug in different things, or, instead of, is the problem really that we've got these, kind of symmetric big iron sockets, where every CPU is this massive, power-hungry, expensive, but very powerful server CPU. Maybe we should move to a more heterogeneous architecture. Or even Intel themselves might want to say, well, gee, maybe not all of our cores are beefy super x86 cores. Maybe we have some, cheaper, lower power, cores that can run other functions that don't necessarily require the full power of a full-scale x86. I mean, do you see this? I mean, it seems to me that, do you see this as sort of pointing to kind of those sort of architectural directions, saying that, all big iron in every socket is maybe not the right way to go?
I think it might be. I mean, it is always tough to predict, exactly where the future is going to go. But I think the idea that you can, do some special purpose things that you're going to do all the time on, if you can do it with a lower end, essentially, set of cores than you could otherwise, it's a great opportunity, I think, the kind of big little thing that you hear people talk about so much.
Hi, just one that kind of follows on from that last question, the power consumption. of the NIC? Do you know about all this?
Yeah, I'm sorry. I'm going to look around to my people to see if I can. Have we talked about publicly about what the power usage is?
I can say much lower than x86.
Okay, there you go. There you go. Yeah, I should have brought a picture of it so you could see. They use some power, but. Oh yeah, absolutely. In fact, it's even low profile height. How's that? Yeah.
Thanks.
So yeah, it's. I mean, I have it in standard servers. It's just fine. So all right.
So regarding installing another OS, are you running, I mean, what's the install process? Are you SBSA compliant or working with the ARM server? I mean, are you running UEFI firmware to boot
Yes.
my Linux on that?
Yes.
Okay. So
And we're in the process. I know that for most of the Linux distributions, to be certified to run, device tree free, there are a set of tests you can run, a test suite that you can verify that you're compliant, and we're in the process of doing that.
Okay, great, thanks.
Yeah.
So is there any other concern about the latency issue? I mean, it looks like before crossing the PCI Express, it has to go through the DDR memory on the board. So do you have any concern about the latency?
Well, I mean, I think for latency-sensitive applications, I think that's definitely a concern. I mean, I don't think any
order of magnitude of which.
I actually haven't. We're at a phase, quite frankly, where right now we're bringing it up. We're making sure that it's functional, and I haven't done any specific latency measurements to know. So I'll be honest with you on that. I don't know. I don't know what the total number is, but I mean, it's going to hit. Yeah, I mean, it's coming off the wire. It's going to hit the DRAM in the ARM cores. It's going to be inspected. It's going to be sent back out another interface again, and then it's going to hit your memory and be DMA'd on the x86 side. So the latency is going to be much higher, but I honestly can't tell you what it is yet. Sorry.
Well, my intuition would be that it would be about the same or no worse because you're skipping a software switching layer on the x86.
Very true. So yeah, I mean, in total picture, it shouldn't be any worse. I mean, if you're looking at raw packet receive just on the x86 side, OVS excluded, clearly it's going to be much higher.
My question might not be specific to Broadcom SmartNIC, but probably generic to all of the SmartNIC. So, for instance, if our majority of workloads is just within host, that means the majority of traffic is just across VMs. So in that case, how do you think that SmartNIC can help in this scenario?
In that scenario, we would still do that processing right now in the default case that I described in the OVS, the standard OVS data path. I mean, that would be defined there. We wouldn't do any cut through where the hardware does forwarding without our knowledge.
Yeah, I mean, since if we're doing all of it just in host software, it could be just much shorter paths, right?
Right.
Compared to the SmartNIC.
Right, and that's kind of the default case when you're doing SRIOV. That pretty typically the default configuration with nothing happening is that all the VS and all the PFs are in the same broadcast domain, and so you can very easily talk to each other. And clearly, people can figure that out most of the time. But in this case, we actually have essentially it's like thinking of direct wires between the OVS data path on the SmartNIC and every individual VF. So any VF to VF conversation that happens is still going to go through the same data path.
Yeah, thanks.
All right, let's thank our speaker.
Thank you.
Thank you.